Problem 12 is based on the response of an LTI system to a cosine input. So we know that if the system has the impulse response HE to the j omega with this magnitude and this phase, then the output of the system is 8 times the magnitude at omega naught times the original cosine omega naught n, and the argument gets added to the phase. In this problem, we are given the magnitude response is absolute value of omega, the phase response is minus omega cube. The input sinusoid is 2 cosine 0.4 n plus 0.3 n. That is x of n equals 2 cosine 0.4 n plus 0.3 u of n. Now ignoring the u of n because we are going to look at the steady state response. What's the center frequency of x of n? We are simply looking for omega naught, which is 0.4 radians. This is A. B is finding the magnitude of HE to the j omega at that frequency. So we are given the magnitude response is absolute value of omega. So it should be absolute value of 0.4, just simply 0.4. What is phi of omega at omega equals omega naught? That is, the given expression is minus omega cube. So its value would be minus 0.4 cube, that's 0.16 times 0.4, that's going to be 0.064. So the output y of n is the original amplitude A 2 times the magnitude at that frequency, cosine, the original cosine was 0.4 n plus 0.3 plus the phase of the filter. That is 0.8 cosine 0.4 n plus 0.364. That's the output yn. And this problem actually is very similar to what you were supposed to do in number 6, but I've taken this off the homework. You don't have to do this. But here the value of the magnitude and phase are not given as equations but rather as graphs. But again, you don't have to do this.